Hello everyone, and welcome to the video lecture series of learning theory of automata and formal languages. We are into video number 2, lecture number 2, where we will be continuing with the concept of deterministic finite automata. So in the previous video, we have come across with the concept of introduction to automata. We have understood a few of the basic terminologies like alphabets, strings. Then also we have seen topics like how to calculate the powers of a string. Okay, so in this particular video we will look into the concept of how to construct a finite automata or how to design a finite automata. So we will try to stick on to the concept of designing the finite automata, and thereafter we will carry forward with the difference between DFA and NFA and their design. Okay, so in this video we will look into the concept of deterministic finite automaton, mainly their definition, representation, and also one example. Okay, so let's check it out what is included in the first slide. In the first slide, we will look into the topic that is known as your finite automata. So basically, what the meaning of finite automata is all about. Finite automata means what? Automata is just a plural form of automaton, which means self-will, self-placed, or we can say self-automatically the carried out of a functionality of a machine, right? So if we talk about a machine, let's say suppose we are having an input, we are having an output, right? And definitely if we have to come across from the input to the output, we need the processing of that, correct? So in order to carry out this processing, this should be an automatic process. So that's why the term is automata, right? Now if we try to design a particular machine which generally tries to accept all different kinds of statements being given by any end user, statements in the form of a language, then we can say that this is an universal machine, right? So that we will discuss in unit number 5, that is all about your Turing machine. But before going into Turing machine, we need to understand each and every machine included in the step-by-step process. Okay, there is a process of hierarchy which will design or which will designate all the different types of machines till we reach the Turing machine. But before that, we need to understand one by one. And after understanding each and every machine, we will try to look into the applications, because then only you will be able to relate that what is that particular machine and where it is being applied. Okay, so let's check it out. What about finite automata means? Finite automata means the terminology it itself describes that we are trying to design a machine which is designate on finite number of input symbols, or finite number of language, or finite number of strings, or finite number of inputs. Got it? So first statement, as you can see here, it is given as finite automata are used for pattern recognition. Okay, so that means for the time being, you just try to think this as a piggy bank. Okay, in a piggy bank you are trying to save money, right? And then later on when you require, you just pull it out from your piggy bank, right? Same way you need to try right now, you need to try to memorize the applications right now where it is being applied. After understanding the concept of automata, finite automata, then you will be able to relate with pattern recognition. Pattern recognition means what? You need to find out certain patterns, and you need to find out that we need to analyze those patterns, and then you need to give a conclusion over that, right? So for that, selecting the patterns, for matching the patterns, for recognizing the patterns, we need to understand the basic understanding of how to design a finite automata. Okay, so later on we will discuss the applications, because you need to understand first automata, then you will be able to relate with the applications. Okay, let's go with the second point. Second point says that it takes the string of symbol as input. That means input is what? String of symbols. Okay, symbols means what? Suppose I have given as A and another A as B. So that means if I combine both, I can say AAB, or I can say ABA. So these are what? These are strings of symbols A and B. Got it? So these are taken as input and changes its state accordingly. Now I have already shown you that input to output, there is a set of processing between them. So these processing are nothing but what? One by one states. So we need to use states in order to represent these particular transitions. Transitions means moving from one place to another place. That means here moving from one state to another state. I will try to explain to you at the end of the presentation to construct a finite automata. They will be able to understand where is transition, what is state. Okay, so as of now, for understanding finite automata, we need to take the input in the form of symbols from a string, in the form of a string from a symbols. Okay, and then we need to look into the transitions, that is changing from state to state. Then at the time of transition, the automata can either move to the next state or can stay in the remaining state depending on the constraint of the particular string. Okay. Then finally, finite automata has two states. One is your accepting state and the other one is your rejecting state. What is the meaning of accepting and rejecting? Accepting means what? I have given, as a user, I have given a particular concept that I need a particular string, say A, B, A. So this is my string given by the user. So what automata will do? Automata will scan each and every string, each and every symbols from the string one by one, and once it is done, it will reach to the final accepting state. Correct? So that means after reading all the inputs, it will reach a final state. That means it is accepted. And if suppose some or the other, the automata is not able to read this particular string, okay, which is not given in the language, then this particular machine will go to what? It will go to a reject state. That means this particular string will not be accepted. So who will decide that this string belongs to the or accepted by the automata? It will be decided by the language that the user is giving. Got it? My language is what? I need to accept A, B, A. But the machine is unable to accept that particular string A, B. That means some way or the other that particular string will go to a reject state. Got it? So definitely overall what we have understood that there will be input in the form of what? Strings. In the form of strings. Thereafter what we will be having? We will be having finite number of states which will define the transitions. And finally, these states can be what? These states can be either accepting or rejecting. Okay. So this is all about your basic understanding of finite automata. Okay. Let's get back to the next slide. Next slide says the formal description of a finite automata. So this formal description means what? General characteristic definition of a finite automata. What are the different components or what are the different characteristics involved in finite automata? First of all, the total number of states. Definitely we need states. So finite number of states is represented by Q. Okay. Then finite set of input alphabets is represented by sigma. Okay. Then Q naught is the initial state. F is the final state. And finally we are having delta, which is nothing but the transition function. Now I will let you know what are all these things. See, Q defines the number of states required in the diagram. Say suppose I am having Q naught, Q1, Q2. So these are the three states that I am having right now. Okay, these are the three states that I am having. With the help of these three states, I am able to accomplish that string. I am able to recognize that string. Clear? Now, in these particular states, I am declaring that Q naught to be the starting state or initial state. Okay, and Q2 to be the final state. Definitely, if you can think logically that if I need to accept anything, I need to initialize something, and finally I need to reach to a final state or final position, right? Then only we will be able to say that that particular concept is initialized and also finalized. Correct? So therefore, we need two important states. One is initial state, one is final state. Okay, and these set of input symbols can be anything. That means alphabet can be anything. It can be 0, 1. It depends on the language what it is asking. It can be A, B, whatever. Coming to the last point, I am just marking as a question mark over here. Okay. Okay, this is a question mark. Why? Because I need to understand this transition function after understanding the designing structure of a DFA or a finite automata. Okay, first I need to understand how to construct the automata. Thereafter, I will let you know what is the meaning of this transition function. Okay. Now, let us go with the next slide. Next slide says that what is finite automata model? Okay, if we talk about the configuration model of finite automata, it requires two important data structures. First is your input tape, okay, and second one is your finite control. Without these two things, it is not possible to accumulate a finite automata or finish up with a finite automata. What the meaning of input tape and finite control is? Look into this diagram. Okay, suppose I have defined a particular string A, B, C, A, B, B, A. So this is a string. So definitely I need to put that particular string into a data structure from where I can read, I can show to the output or show the output to the user, right? So one data structure that we'll be using is input tape, where the string will be stored. Another data structure will be used, that is your finite control. What the finite control will do? Finite control has the capacity to read the particular string alphabets one by one and then finalize that whether that string is accepted or rejected. Got it? So this is the overall configuration of a finite automata. Clear? One is what? Input tape, and the other one is your finite control. Finite control generally decides whether or generally controls whether the particular string should move to the next state or should present in the present state. Then overall what it decides, it generally reads the particular string and then produces the output. Got it? So this is all about the configuration model of a finite automata. Let's check the next topic. The next topic is types of finite automata. Overall, I have defined only the basic content which is required right now. But if we want to look into the main concept of different types of finite automata, I will let you know. If we talk about finite automata, we can divide finite automata into two categories. One is finite automata with output, okay, and the other one is finite automata without output. Okay, finite automata with output and finite automata without output. With output is generally divided into two categories. One is Murray machine and the other one is your Mealy machine. Okay, these are the two types. And if we talk about finite automata without output, this is nothing but this one, finite automata. Okay, whatever I have mentioned over here. So without output generally comprises of two main types, deterministic finite automata and non-deterministic finite automata. Okay, deterministic finite automata and non-deterministic finite automata, and one more type is there which I have not mentioned over here, that is your epsilon NFA. Okay, one more type is there, that is a epsilon NFA. Okay, so first we will try to learn deterministic finite automata. We will try to construct some of the machines, okay, based on certain languages, and then we will look into the non-deterministic finite automata concept. Clear? So this is the general hierarchy or types of finite automata. Okay. Let's go into the next slide. The next slide says what is about deterministic finite automata. Okay. Let me just give you a clear-cut idea about what is the meaning of deterministic, because only the difference lies over here. Deterministic. First of all, I need to understand one more thing clearly, that I should have first of all a language. Okay, I should have first of all a language. From the language, what I need to have? I need to have the set of strings. Okay, I need to have the set of strings, and from the set of strings I can design the finite automata. So this hierarchy always try to remember. I will be given a language. From that language, with your logic, I need to find out what are the strings. After accumulating all the strings from the language, I need to check whether that automata is able to accept those strings or not. Okay. Once all these strings based on the language are accepted by the finite automata, I can say that that is your final accepting one. Okay. But in this scenario, what is the meaning of deterministic? My question is that what is the meaning of deterministic? Deterministic means that the machine is determined. The terminology itself says that the machine is determined that whether whatever strings is present in that particular language. Okay, these strings is what? These strings are collection of symbols only. Correct? Collection of symbols means what? Collection of alphabets. Symbols is nothing but the alphabets only. Correct? Suppose the alphabets are 0 and 1. This means what? The finite automata needs to concentrate on each alphabet and should produce exactly one transition. Again, I am repeating that the finite automata should concentrate on the strings, should concentrate on the symbols, that is nothing but the alphabets. And what are the alphabets in this particular language? This is 0 and 1. That means This finite automata needs to concentrate both on 0 and 1 and should do one transition, exactly one transition, not more than that, not less than that. Alright? That's why it is said to be determined. That's why it is said to be restricted. Okay? Now, if you look into this point by point, DFA refers to deterministic finite automata. This is a basic abbreviation, right? Then we can say deterministic refers to uniqueness. This is one point, that uniqueness, that I need to concentrate on both the symbols and I need to transfer one transition exactly once. This is one uniqueness point. Second point is that see that in DFA there is only one path for specific input. This is very, very important point of DFA, that in DFA there is exactly only one path for specific input. That means if we are having two inputs 0 and 1, exactly one path should be there. So that path can go to a next state, or that path can be into the same state also. So that depending on the language that is been given. Okay. Comes to the last point. DFA does not accept the null move. See, as I am letting you know that 0 and 1, these are the two input symbols. DFA says that for both the input symbols there should be exactly one transition. If there is exactly one transition, can it be possible that there is no transition? It's not possible, right? DFA does not accept null move. Null move means what? Null transition, no transition. So that is not possible in the case of DFA. Alright. So that means overall, if I sum up these points, I can say that DFA concentrate on one particular point, that whatever alphabets are there, for both the alphabets or for both the input symbols, it should have exactly one transition. Not more than that, not less than that. If not less than that, then definitely what? No null moves will be there. Alright. So this is all about your deterministic finite automata. Let's check it out. What is the formal description of it? Formal description says exactly similar to what you have learned in finite automata. Only the difference will lie everywhere over this one, transition function. Only the difference lies in the transition function. Finite automata, DFA, NFA all comprises of 5 tuples. That is Q, finite set of states, sigma, finite set of input alphabets, input symbols, Q0 is the initial state, F is the final state. So you might be having a query that whether Q0 will be always the initial state. No, you can name any. This nomenclature is not restricted. You can name anything. You can name capital A, you can name 1 also, you can name X also, whatever you want. And same goes with final state also. These states are nothing but alphabets only. It depends on, it should not be equivalent to what input alphabets is given or input symbols are given. Both should be different, both should be well identified. Okay, that you need to remember. But only the difference lies in this transition function. Why so? Because in DFA we are restricted that for every input alphabets we need exactly one transition. That means what I need to check? I need to check the total number of states, and for every states I need to check what? The input alphabets. This is my prior concern, and what it can do, it can go either to the present state or it can go to the next state. So that's why this is the transition function for the given diagram. So if you can look into this concept, I have already given you a question mark. Now I can remove it. Now I can remove it. Transition function defines a particular function which actually explains the movement of the particular input symbol from one state to another state, or maybe from the same state movement. So it generally defines a particular function for the transitions, for the movements. Clear? So now we have understood the formal description of DFA. Same goes with NFA also. NFA, DFA, finite automata, epsilon NFA. All are having the same formal description, 5 tuples only. Only the difference where it will occur, transition function. So this is a very important question in MCQ point of view, in competitive exams point of view, in your final exams point of view. That the question generally been asked that what is the difference between DFA and NFA? Second question, what is the difference in the transition function of DFA and NFA or epsilon NFA? And one more point is there that yeah, these are the 2 possible questions that can be asked from DFA and NFA if they ask for differences. Okay. So now let's go with the graphical representation part of the DFA part. So if we talk about DFA, if you are looking into DFA part, we need to design the DFA. If we talk about design, then definitely representations are there. If we talk about representations, what are those representations? Let's check it out here. So first state is that the state, see, first of all, one more thing that you should keep in mind is that what are the things that we need to concentrate while designing a DFA? That is the first thing, right? So let's check it out. First of all, we need to concentrate states. Okay, states will be the one. Then in these states, I need an initial state, I need a final state. Okay, next one, what I need input alphabet, or I directly write input symbols. Input symbols are nothing but the alphabets that is being given in the question. And question will come in the form of what? Language. I will let you know what is the meaning of a language. So the question will come in the form of a language. From the language, you need to identify what are the strings, and based on those strings, you need to design the particular DFA. Clear? So these are the possible things, these are the possible representations which are required. States, initial states, final state, and then input symbols, and definitely the transitions. Okay, so these are the 5 different you can say points or components with the help of which you can design a DFA. Okay, now let's check it out graphically, how it is being represented. Okay, so if we look into the representation part, okay, if we look into the representation part, the state is represented by vertices. Okay, so how I will represent the states? The states will be represented by, 1 minute. Okay, the states will be represented by circle. Okay, the states will be represented by circles. Okay, then the arc labeled with an input character show the transitions. Okay, that means if I have one state, another state, so the transitions will be represented by a directed arc, directed line. Okay, these will be showing the transitions. Then initial state is marked with an arrow. So initial state is represented like this, and the final state is denoted by a double circle. Final state is denoted by a double circle. So this is your initial state. Okay, and this is your final state. Okay, so this is all about the graphical representations of DFA. Okay, and finally we come across with the last presentation of today's session, and here I will try to design a finite automata, not a DFA. I am just cutting it up. Why? Because I need to first understand a simple diagrammatic representation to understand the construction of finite automata. In the next lecture, we will look into how to construct a DFA, and we'll check it out few of the examples over that. Okay, so if we need to construct a finite automata, okay, we need to first understand what are the representations. State represented by circles. Okay, initial state, arrow followed by a circle, final state, double uncircles. Correct? So that means what we need to find out, we need to find out a language having length equals to 2 over AB. Okay, so that means I need to construct a language, okay, where alphabet is given as what? A comma B, and length equals to 2. Length equals to 2 means what? Alphabet to the power 2 we need to find out. Okay, I have told you about the strings. I have told you how to calculate the power of strings. So power of strings means nothing but power of alphabet only. Okay, so sigma to the power square means what? Sigma into sigma, and 1 sigma means what? One alphabet comprises of A comma B and A comma B. So if we merge both of the things, then it will be AA, AB, BA, BB. That's it. A, B, B, A, B, B. That's it. So finally, if we look into length equals to 2 for the alphabets A and B, we will get the language as this one. So therefore the language will be what? The language will be AA, AB, BA, BB. So what I need to design? I need to design a finite automata which will accept these particular strings. Okay, I need to design a particular finite automata which will accept these particular strings. Always keep in mind that while we design a finite automata, it is not sure that we need to design as an overall diagram. No, we need to design one by one. We need to concentrate on every possible strings present in the language, and then we need to design the automata. So here I will stop here. And in the next video, I will show you how to design this particular finite automata, and there I will put the restriction in order to explain what is the concept of DFA. After that, we will check few more examples on DFA, and then once DFA is done, you will be very much sure to how to design a NFA also. So this is all about your today's video. In today's video, we have tried to understand the characteristics or the components of DFA, the formal description of DFA, DFA main definitions, and a basic understanding of the language. Okay, so in the next video, we will come across with the designing part of this particular DFA along with few more examples. So thank you for watching this video.